In today's lesson, you are going to learn about the METAR. In aviation, weather plays a very important role in the day-to-day operations. In aviation, the weather information of an aerodrome is broadcasted in a report called METAR, Meteorological Aerodrome Report. METAR are published in a fixed format every half hour. You can learn all the METAR abbreviations by referring to this lesson. Let us take an example of METAR of Paris International Airport and decode it. The first element of METAR report is the report code name METAR. It is a string of abbreviations which denote various weather conditions around the aerodrome. METAR second element is the airport identifier. Lima Foxtrot Papa Golf. It's ICAO 4-letter location indicator. It stands for Paris International Airport. The third element of METAR is date and time group. The first two numbers are the day. In this example, it is the 13th day of the month. The next four numbers indicate the time. It is 1130 Zulu. Zulu stands for Universal Coordinated Time. Next element is report modifier. Here you will get auto or COR. Auto stands for automated report. It indicates a fully automated report with no human intervention. All observations are based on sensors reading, automatically read by the system, and report is generated accordingly. If an observer takes or augments observations, this auto tag does not appear. COR stands for corrected observation report. Sometimes in place of auto, we will observe COR. It indicates a corrected observation. Next are the winds. Normally, there will be a 5-figure group to indicate the 10-minute mean wind followed by wind speed units. The first three figures indicate the true wind direction and the last two the wind speed. Knots KT is the unit used for reporting wind speed in aviation message. Values of wind direction less than 100 degree shall be preceded by 0 and a wind from true north shall be reported as 360. Values of wind speed less than 10 units shall be preceded by 0. So here 090 KT indicates that wind blew from 090 degrees at 090 knots. When a wind speed of less than 1 knot is reported, it shall be indicated as calm. Calm shall be coded as 00000 KT. The wind direction may be considered variable if during the 2-minute evaluation period the wind speed is 6 knots or less. So here we will write VRB 02 KT. It means wind is variable with mean wind speed of 2 knots. Next element is variable winds greater than 6 knots. The wind direction shall be considered variable if during the 2-minute evaluation period it varies by 60 degrees or more when average wind speed is greater than 6 knots. So here in this example we have been given VRB 12 KT. So it means that variable wind with mean wind speed of 12 knots. Here, if during the 10 minutes period preceding the observation, the total variation in wind direction is 60 degree or more, but less than 180 degree, and the mean wind speed is 3 knots or more, then we will report just like this, 310 degrees 15 knots, and wind is varying from clockwise direction 280 degrees up to 020 degrees. So here from 280 degrees to 020 degrees, the total wind variation is more than 60 degrees, but it is less than 180 degrees. Gusts are indicated by rapid fluctuations in wind speed with a variation of 10 knots or more between peaks and lulls. So here it has been shown like this. First, wind data have been given 31015 kt and it is gusting up to 30 knots. Next element is visibility. So here 4000 means a horizontal visibility of 4000 meters. So this is the prevailing visibility at Paris airport at this time, 1130 Zulu. So visibility shall be reported as follows. It has to be reported in steps of 50 meter whenever the visibility is less than 800 meters. And visibility has to be reported in steps of 100 meters between 800 meters to 5 kilometers. And once it is above 5 kilometers, visibility will be reported in kilometer steps. And suppose if our airport is having visibility 10 kilometer or more, then in METAR, here the values will be like this, 9er, 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 9er. So whenever visibility will be given in 4, 9 figures, so it means that visibility is 10 kilometer or more. Sometimes we will observe M before visibility, where M stands for minus or less. This indicates the visibility is less than whatever number is reported. So if we see a minus 2000, it means that visibility is less than 2000 meters. Similarly, you may also see a P before the number, like P2000. This means the visibility is forecast to be more than 2000 meters. RVR observation should be made 10 minutes average and reported in current weather reports whenever the horizontal visibility or runway visual range is less than 1500 meters. Runway visual range starts with the letter R followed by the runway designator and a slash followed by the RVR readings in meters. So here it will read like this: runway visual range on runway 27 greater than 1200 meters. If RVR trends can be measured, then we have three different letters U, D or N. These will follow after the RVR value and these will indicate increasing, decreasing or no change in the RVR trend. So in this example, we have been given RVR runway 27 1200 meter increasing. U means increasing. Next, you will see the description of the weather. So plus RA represents heavy rain. Plus means heavy and RA represents rain. And next we have been given BR, Bravo Romeo. It is the METAR code for mist. So you should learn most of these abbreviations code by heart. Weather description is divided into two parts. The first part is qualifier and the second part is known as weather phenomena. So if you will see the first column, it stands for intensity. Plus stands for heavy. Minus stands for light intensity. And if there is no sign of plus and minus, it is moderate intensity. And VC stands for in the vicinity. So description to the weather phenomena further, if you will go through like this, MI stands for shallow, SH means shower, TS means thunderstorm. Then thereafter some precipitation codes are there, DZ, drizzle, RA, rain, GR, hail. So I request you to pause here and read these codes yourself. Now next is Victor Charlie Bravo Lima Sierra Alpha. So if you will see that code table, you will find out VC means in the vicinity, BL stands for blowing. It is describing the weather phenomena as blowing, and SA stands for the obscursion is sand. Either it can be precipitation or obscursion or something other. So here sand comes under obscursion. So it's blowing sand in the vicinity. So we will decode VC in the vicinity, BL blowing SA. So it is blowing sand in the vicinity. So here plus SHRA means heavy rain shower. Similarly, if SHRA is given, so there is no plus or minus, so it means it is moderate. So it is moderate rain shower, or you can simply say rain shower. So here remember that a descriptor without a plus or minus sign means moderate intensity. Thereafter we will observe sky condition. Cloud groups consist of 6 characters under normal circumstances. So here OVC010 means overcast at 1000 feet. So cloud groups consist of 6 characters, which we have said under normal circumstances. The first 3 indicate cloud amount. Sky is divided into 8 parts and each part is called octa. If there is no cloud, it will be reported as SKC, means sky clear of cloud. If cloud cover is 1 to 2 out of 8 part, it is called few. If cloud cover 3 to 4 out of 8 part, it is called scattered. If cloud covers 5 to 7 out of 8 part, it is called broken and written as Bravo kilo number. And if cloud covers 8 out of 8, so it is completely covering the sky, it is known as overcast. So it will be written as OVC. So here the last 3 characters of cloud group indicate the height of the base of the cloud in the 100 of feet. So the height of cloud is above aerodrome elevation. One more thing, the numbers can be confusing. So here is a trick. Always add 2 zeros to the number. So when you add 2 zeros to OVC 010, you will get overcast 1000 feet. At mountain stations, when cloud base is below station level, the cloud group should read like this: scattered / or few //. So here / means cloud height is not available or the cloud are below airport elevation. Then significant convective clouds like CB or TCU are reported in METAR in the cloud group. So here we have mentioned broken 010 and our convective cloud is Charlie Bravo at 3000 feet. So it is at 3000 feet. Clear skies shall be coded in the format SKC or CLR. So CLR is the abbreviation which is used by automated stations, and it will indicate that there is no cloud layer detected at or below 12,000 feet. So sometimes in place of CLR we will get SKC. So SKC will be used by manual stations to indicate that no layer of clouds are present. So difference between CLR and SKC is SKC is done by a manual station and CLR is done by automated stations. CAVOK stands for cloud and visibility OK. So simply you think that in place of visibility, present weather and cloud, you will mention CAVOK in your METAR. You will observe this. Whenever visibility is 10 km or more, there is no cloud below 5000 feet, there is no CB or TCU cloud, and there is no significant weather phenomena in the vicinity of aerodrome. So during that time, you will find this visibility is damn good and you can carry out VFR operations without any difficulties. If you see a double V on your METAR report, it is probably because you have fog or dust in the area. They are not any cloud, but you won't be able to see much. So here V003 means vertical visibility 300 feet. When the sky is obscured, but the vertical visibility cannot be assessed, the group will be read as VV///. The next element of METAR is temperature and dew point. If you see a double V on your METAR report, it is probably because you have fog or dust in the area. They are not any cloud, but you won't be able to see much. So here VV003 means vertical visibility 300 feet. When the sky is obscured, but the vertical visibility cannot be assessed, the group will be read as VV///. The next element is temperature and dew point. So here 09 first two letters stands for temperature /07 stands for dew point. If we have to report a temperature in negative, so we will simply put M before that number. So suppose if we have a temperature of minus 9.5 degrees Celsius, so we have to report it as minus M09. The final section of the first part of METAR is the altimeter setting. Here Q stands for altimeter and the number following is the altimeter setting. So here Q1016 hectopascal. Now we will discuss some supplementary information. So recent weather. Significant recent weather observed in the period since the last routine observation will be reported by using the code letter for weather preceded by the letter RE. RE stands for recent. So if we have observed thunderstorm, so we will write RETS. It means recent thunderstorm. Trend, first we can write become. It is becoming when the trend is lasting for more than 1 hour. We can replace becoming by tempo, which is temporary, means it is used when the trend is valid for a period less than 1 hour. So here we have written, you can guess like this, becoming from 1030 UTC till 1130 UTC. We can also write no sig. So it will replace the trend group with no significant changes are forecast to occur during the 2-hour forecast period. So weather will remain as it is, whatever have been reported. We are not expecting many changes. Then there is NSW. It is to indicate the end of significant weather, means no significant weather. So only those elements for which a significant weather change like visibility, weather or cloud is expected, it has to be included into trend. So first part of METAR ends here, but wait, the other part of METAR is also has some very important information. So METAR has two major sections. First is known as body, which is consisting of a maximum of 11 groups, which we have already discussed. And the second part is known as remarks. It is consisting of two categories. First is automated, manual and plain language, and the second one is additive and maintenance data. So if we will see the top, we will see that yellow we have already discussed, and it was the body. which was consisting of total 11 groups. If we'll read like this, the report name is METAR. It is for Paris station. Date is 13. Time is 1130 Zulu. It is automatically reported. Winds are 090 degrees, 09 knots. Visibility is 4,000 meters. Here we have given one example for RVR. If RVR is given, it will be like RVR for runway 27 is 1,100 meters. Plus means heavy rain. Then BR is mist. Vertical visibility / means it's not available. 09 is temperature in degrees Celsius / 07 is dew point in degrees Celsius. Then QNH altimeter setting is 1016 hectopascal. So now we will be going to discuss about the white part, which is the remark section. So remarks shall be included in all METAR. Remarks shall be separated from the body of the report by space and the abbreviation RMK. If there are no remarks, the abbreviation remark is not required. So there are 36 different types of report you will see in the remark section, and they are listed in the table below. So first is volcanic eruptions. This remark is self-explanatory. It will have the name of the volcano and the location of the ash cloud. Funnel clouds. You will see tornado, funnel cloud or water spout with the time it began and ended. For example, tornado B136NE would indicate that a tornado which began at 13 minutes past the hour was 6 statute miles northeast of the station. Type of automated station. This is a common remark. The alpha 01 indicate the station has no way to differentiate between types of precipitation. It may be rain or snow, but you won't know. And alpha 02 on the other hand can tell the difference between snow and rain. The higher the number, the more advanced the equipment is. Peak wind. The first three number 350 or 280 here indicate the wind direction it is coming from. The next two numbers 45 indicates the wind speed in knots. The number after the slash is the time after the hour. The 15 in this case mean the peak wind happened at 15 past the hour. The number after the wind shift is the time the wind shift happened. So in this example, the wind shift occurred at 30 past the hour. If the wind shift happened due to frontal passage, you will also see a FROPA, which is known as frontal passage. Next is tower or surface visibility. This remark is useful because this will tell you if tower is able to see you. This is control tower visibility of 1.5 statute miles. Variable prevailing visibility. This is important to let you know that conditions are changing now. Visibility that was varying between half and 2 statute miles. Sector visibility. This can be useful if only a certain part of the airport has bad visibility. Directions defines the sector to 8 points of the compass in the sector visibility in statute miles. For example, a visibility of 2.5 statute mile in the northeastern octant will be quoted as VIS northeast 2.5. Visibility at second location. Some airports are able to report visibility in several areas on the airfield. Next is lightning. So OC, NL, LT, IC, CG. It means that occasional lightning of less than 1 flash per minute in cloud and cloud to ground. So here you will think that it's very complicated that how to decode it. But once I will give you a table. You will find that it's very easy to find out the lightning, and lightning is a very important aspect of aviation, and safety is involved. So we should be thorough in decoding this lightning element. So type of lightning is given. CG means cloud to ground. It's so simple. Type of lightning, C stands for cloud, and it's going where? It's going to ground. IC, it is inside cloud, in cloud. CC is from cloud to cloud. Then C stands for cloud to air. So it's very simple. It comes in the type of lightning. Now we will decode the frequency of lightning. OCNL, it stands for occasional. So when we will report occasional, when the frequency of lightning is less than 1 flash per minute. So during 1 minute, we have observed less than 1 flashes. Then frequent. If we are observing 1 to 6 flashes per minute, then it will comes under frequent one, and it will be reported as FRQ. If we are getting is continuous, CONS, we will mention it as a code, and it will be like more than 6 flashes per minute. So here we have been given OCNL. OCNL stands for occasional. LT stands for lightning. IC stands for in cloud. CG stands for cloud to ground. So if thunderstorm is reported, it's recorded, it has to be reported also. So if TS is given, it means that thunderstorm within 5 nautical mile of the airport. If VCTS is given, vicinity thunderstorm, it means that within 5 to 10 nautical mile of airport, lightning has been observed. If lightning distant have been given, that it means that it is beyond 10 nautical mile but less than 30 nautical mile of airport, lightning has been observed. Then beginning and end of precipitation. This one requires you to know your basic types of precipitations like rain and showers and etc. So B stands for again for begin, and E stands for end. Also, the time is always minutes after the hour, because you know that hour you can decode from the METAR report itself. So if 35 is given, it means that 35 minutes past the hour. So we have been given a report like this: RA beginning 05, ending 30, SN beginning 20 and 55. So we will decode it like rain began at 5 after and ended at 30 after. Then it started snowing at 20 after and it ended at 55 after. So it's that simple, but just giving a complete information about the beginning and ending of a precipitation. So by this way, if we will practice this again and again, we will find it very easy and we will remember everything. We will not to remember that this is precipitation. You simply say that RA is rain, B is beginning, 05, okay. So 5 after, so ending 30 after, then it is snow, beginning 20 after, then ending 55 after. So it's that simple. You just keep practicing it and you will be going to master your METAR series. The next is beginning and end of thunderstorm. Same, B will stands for begin, E stands for end, and TS, that is thunderstorm. So I will decode it here for you: TS B01, then 59 and 30, which means that thunderstorm began at 0159 and ended at 0230. Now next, thunderstorm location and movement. So if we have been given TS SE movement northeast, so it means that thunderstorm are moving from the southeast of the reporting station to the northeast. It's that simple. Then hail size. The acronym for hail is GR, and if half is given, it means that we are talking about hail size of ½ inch. Then virga. These are the cloud with precipitation, and these will never reach the ground. So if it is example, it will be given like virga and direction will be given. So it is southeast. Then obscursions. So sometimes other than precipitation, we will be having obscursions like here smog broken 002 means smoke is causing a broken ceiling of 2. After 2 you have to add 2 zeros whenever cloud is given. So it is smoke is causing a broken ceiling of 200 feet. It's simple. Then variable sky conditions. So whenever variable is given, so there will be V will be provided in between. So suppose two clouds are there. It is mixing and churning and you cannot distinguish that what is becoming what. So here it is, we have given like broken 014 variable OVC. Means that there is a 1400 foot layer that varies between broken and overcast. So it's a mixing one. Then significant cloud types. So there are multitude of different cloud types such as CB, TCU, then ACC, then standing lenticular SL, then cirrocumulus, then altocumulus, stratocumulus. So these clouds will always be followed by a cardinal direction. Suppose we have been given TCU west. So towering cumulonimbus in west direction of the reporting station. Then ceiling height at a second location. So when the ceiling height at a second location on the reporting station has a lower value, then only you will find it in the remark section. So here we have been given CIZ 002 runway 11. So if this second sensor is reading this one, so definitely this value is less than the mean sensor value. So it is given as ceiling is at 200 feet, runway 11. A second sensor is reporting this one. Then pressure rising or falling rapidly. It's a very important to know that weather is going to change very soon. So whenever we are going to get this information, this will be like this: PRE pressure rising rapidly RR, and then we have been given pressure PRES falling rapidly FR. So it's very simple to decode this one. Just go through it once, twice, thrice, and you will practice it. Then sea level pressure. So if SLP is given, it stands for sea level pressure. 988 means 988 hectopascals. Sorry, I have mentioned here 998 hectopascal. Then if SLP NO is given, then sea level pressure is not available. Simply NO means not available. Then aircraft mishap. If this is given, then some aircraft mishap have been happened, but it will not be transmitted in the report. It will be simply written as aircraft MSHP. That's all. No spacey means at manual stations where species are not taken, the remarks no spacey will be coded. So it means that until next METAR, you cannot expect any weather recordings to be available to the pilot in command. Now snow increasing rapidly. So snow is SN, increasing INCR rapidly. R stands for rapidly. 3 inches to 15 inches. It's very simple. 3/15 means it was 3 in the last hour. Now it has gone up to 15 inches. Then other significant information, whatever the station want to add, he can add here, but it should be in plain language. Now, as we have discussed earlier, that remark section has 2 parts. So first part we have already covered. The second part is additive and automated maintenance data. So here we will see. Here the first is precipitation. So P stands for precipitation and the numbers that follows indicate the amount. So here 0015, or here if in this green text, if we have given 0002, it means that 2 divide by 100. You simply do in this way. So of an inch of precipitation fallen in the last 1 hour, so P0015 means you just divide 15 by 100, so it will be comes out to be decimal 15 inches has fallen in the past hour. So this much precipitation has fallen in the past hour. So next is hourly temperature and dew point, which is given in Celsius. So it is like T0026. So first 4 numbers will represent temperature and last 4 numbers will represent dew point. So after T, this 0 has been given. So if 0 is given, it is representing a positive temperature. And if it will become 1, then it will becomes a negative number. So our number is 026. So it simply means this. You divide 26, you just divide 26 by 10. So we'll get 2.6 degrees. And as the first number is 0, so it's a positive one. So it's positive 2.6 degree is the temperature. Now we'll go for the second part. That is 1015. It's a dew point. So it's beginning from 1. So 1 stands for negative. So it's minus, then 15 you divide by 10, you will get minus 1.5 degree is your dew point. Then sensor status indicators. If you have RVR no, so simply means that RVR is not available. Then peak wick indicator no, it's not available. So these all are the automated sensor informations, but due to unserviceabilities, these are not available at the time of recording. So PNO means that rain gauge sensor is not operative. Then freezing rain sensor, freezing rain not operative. Then thunderstorm not operative. Thunderstorm or lightning detection system is not operative. Then secondary visibility sensor not available. If you have secondary ceiling height indicator sensor and that is not available, it will come as CHI-NO. Then you might have seen dollar also. It's a maintenance indicator. So whenever it is coming, that it means that some fault has been observed and maintenance is required. So we have reached to the end of this session, and before you leave, please take 2 minutes to leave a comment about your experience with this presentation. Wish you a wonderful day ahead. Thank you.